Hello and welcome back to the second video in lesson 16, and now I'm into kind of the second third of the block. So I talked about standard deviation and variance in the first video. Now I'm going to talk about quartiles and interquartile range in the second video, and the third video will deal with z-scores and percentiles. So here with quartiles, just continuing along, quartiles divide a set of data into 4 equal-sized groups. So we are quartering our data. Okay, that's what the definition of a quartile is. So basically what ends up, we know from the first lesson in this unit, we can find x bar, or the mean, okay, or median I should say, sorry. Now we're using median. All right, so in the previous one when we were talking about standard deviation and variance, we used a mean. Now we're using median, and median is also referred to as Q2, okay, the end of the second quartile. All right, we have then halfway in between what we call the first quartile, known as Q1, and here we have the lowest data, or datum I should say, so it's the lowest value in our data. Okay, going the other direction, we will have our third quartile. So this is where the third quarter ends. So the third quartile, which is known as Q3. And then at the very, very end, we have our highest datum, or the largest value in our collection of data. Okay, that's all we're doing here. We're just breaking our data set, or our marks, or our measurements of height, into 4 evenly sized groups. The interquartile range, this is the range of the middle half of the data, okay? And what we do is Q3 and Q1 and Q2 are numeric values. So we just simply take Q3 and subtract Q1, and what we'll get is we'll get a number or a value, okay? And that value is the interquartile range. So I should just put that in there rather than number. So an interquartile range. All right, that's what we get. So Q3, Q2, Q1, they're numeric values, and I'll show you an example. So the larger this range, so the larger Q3 minus Q1 is, the larger the spread of the central half of the data. And that's what's important to us, is that central half, all right? Because that tells us how far apart half of that data is. So we are looking for that interquartile range. Now your semi-interquartile range is half of the interquartile range. So simply put, it is your interquartile range divided by 2. So let's put a room here. So it is interquartile range divided by 2, or your Q3 minus Q1 over 2. Okay, and this indicates, how clustered is the data around the median. So that gives us an idea of the distance between Q1 and Q2, or Q2 and Q3. Okay, we'll talk about its application in a little bit here. Finally, the last thing I want to talk about is a box whisker plot. You'll see them. It's a graph that just illustrates our quartiles. So basically, you get a number line. I'll show you how you can do this in Google Sheets semi-easily. You might find a better application that makes the box whiskers, but for my purposes, it'll give you a general idea of how to do it. Basically, what you do is take this number line, you find the midpoint, or the median, Q2. So I'm not going to put a number on it. And then you'll have your number line going in both directions. And what you'll do then is you will find, here's Q3, here's Q1, here's my lowest datum right here. I'll put an L. Here's my highest. And what happens is you create or construct a box that goes from Q1 to Q3. You put a line where Q2 is, and then you extend the whiskers out. So this is kind of like looking at the front of a cat. There's its nose, and there's the whiskers. And what it is, it's a graphical representation to show us that you know, the interquartile range, the data is evenly spread. Okay, that box looks symmetrical. But when we look outside the box, we see that the lowest data to Q1 is a lot closer than the highest data is to Q3. So we know we got a bit of a skew in our data in this direction, okay, which could be an outlier. Okay, this could be an outlier down here. We don't know, but at least we know that there's not symmetry in the data in this case. All right, so that is what your box whisker graph will look like. So as we head into this next example, I'm using the same information, same people and the heights that I had before. And in order to do quartile range and box whisker plot and so on and so forth, I need to get this data in order. And again, in the old days, you'd have to sort this manually. However, now spreadsheets make life so much easier. So I highlight the names and the numbers because you want Sammy to stay with 160, you want Shannon to stay with 170. So we are going to select our data. And from there, we will select the data tool. This allows us to do some simple manipulations with the data. And we have all this sorting. We want to pick sort range because I am trying to sort the B column. I want the heights sorted. I don't want it sorted alphabetically. So the spreadsheet will sort this and put this alphabetical if I want, or it'll put this in smallest to largest. So I have to tell the spreadsheet what I want sorted. So I highlight the data so that the names and numbers stay together. Hit data, I go sort range. I want to sort, and you only selected 2 columns. I want to sort column B. I want to go from smallest to largest, A to Z. Okay. When I hit sort, and now we come back, we see that Ellen's now on top. We can see here's Sammy, she got bumped down here, but the numbers go from smallest to largest. I'm going to take a picture of that. I'm going to move that into the note so that I can talk about and show how we finish off this particular part of the lesson. All right, so doing a quick count, I know I have 14 people. All right, so we want to find the median. All right, and again, we can do that from our Google Sheets. So I've gone back to the spreadsheet, and what I'm going to do is I'm going to find the median. So I'll do that down here, since it's information I do need. Equals median, select it, select my heights, and I mean, it'll tell me that it is 170. So that means that these 2 are my actual median. So it's going to be in the middle, or it tells me the location. Now I could have just counted down. I know I have 14 pieces of data. So if I want 1, 2, 3, 4, 5, 6, 7, I have 7 on top, 7 on the bottom. So it's going to be the average of the middle 2 in order to get the median. So now that I know the median's at 170, which it could have been just as easy to do it from here, I know that at 170, here's my median, or here's my Q2. All right, so I'm just going to label these off to the side. I now know Q2 is 170. It's going to be the average of those 2. Now, just thinking about how to show it, I've got 7 pieces of data. So Q2 splits it evenly. So that means I'm going to need, in order to split that again, I'm going to need 3.5 because I got to split the 7 in half. So I need 3.5, which means that 1, 2, 3, it's going to be in the middle, Q3. All right, it'll be in the middle. Whoops. Nice counting. You're likely saying, what is he doing? 1, 2, 3. 1, 2, 3. So that means that this value right here is Q3. There's an even number of data on either side. All right, so we have Q3. My Q3 value is 180. Same idea up top. 1, 2, 3, and I'm counting the other way too. 1, 2, 3. This is the middle piece of data. That's my Q1. Checking. There's 3 data sets, 3 data points there, 3 there. So I am in the middle. So that tells me that Q1 is a value of 160. And all those are measured in centimeters. So determine the quartile and interquartile range for the height of the people. So we have our quartiles, our interquartile range, Q3 minus Q1 equals 180 minus 160. So our interquartile range is 20 centimeters, and our interquartile, Q3 minus Q1 over 2, which is 20 over 2, or 10 centimeters. Therefore, our semi, so therefore the semi-interquartile range is 10. All right. Now, creating your box whisker plot, like I said, it's basically just your number line. So I'll just create a number line. My median was 170. And I'm even going to be, this is how much I emphasize accuracy here. Try to be, semi-accurate 180. And on the other side was 160. All right, so there's my Q2, Q3, Q1, and now I look for my upper and lower data. So it goes from 150 to 205. So it looks like, oops, this should be, I guess if I'm going to do it a little bit accurate, that's 10, so that's about 10. I guess I wasn't too far off. 160. So same distance, that's 190. Same distance again. So that's 200, so 205 is about there. So there's my upper. My lower was 150. So there's my lower. Dot. Draw in my box. Label it. There's my box whisker plot. All right. And you can do this. I'll show you quickly how you can do it using in the spreadsheet program if you want. And it's kind of handy to know how to do it if you're doing a project or piece of homework. So if you go back to Sheets, it's all in here. I just go Insert, and I'm just going to go a drawing. All right. So I just pick a line. There's my line. Pick a shape. Let's go with our rectangle. Go back to my lines. Kind of shows me where the midpoint is there. Not overly accurate, but there we go. And then, and then you just label your values. So our midpoint was 170. And then we got 180. I'll just do all my values all at once here. 160, 150, and I think 205 was my upper. So just moving it around a little bit there. What am I moving the 180? Oops, it should go there somewhere. At my 150 roughly. Oops, 150 should be down further. And like I said, if you find an internet app that does this for you, you go ahead, but it doesn't matter to me. There you go. All right, so if you want to put this into a homework sheet or a project, it's that simple. Okay, so there is your quartile and interquartile ranges taken care of. A little bit longer for me to explain, a lot quicker for you to do. Last video then is going to deal with percentiles and Z-score. And we'll see you in the next video.